Now we are supposed to show whether asymmetric relations are closed under these operations or not. So what is that we are trying to see here is, if we take a relation which is already known to be asymmetric and if we apply any of these operations, what happens to the resultant relation? What type of relation it is it asymmetric or not? That is what we are supposed to find out. Now what can you say about subset operation? Which means if I take a symmetric relation and if I take a subset of it, what can you say about the result? That is the meaning of it. So now if R1 is a relation which is asymmetric, and what does symmetric mean? It will not contain any symmetric pairs including x comma x, right? Now if you have such a symmetric relation, now if I take a part of it, is it going to be asymmetric or not? Yes, it is going to be asymmetric. The reason is, by taking some of the elements of the asymmetric relation which does not contain any symmetric pairs, we will not be adding any symmetric pairs, isn't it? Already it does not contain symmetric pairs. Now if we take a part of it, it will definitely not contain symmetric pairs. Therefore we are not adding more symmetric pairs. So the result is going to be asymmetric. Therefore what can we say? Asymmetric relations are closed under subset operation. Now what about superset operation? Superset operation means we take a symmetric relation and if we add more ordered pairs to that relation, what can you say about the result? Now I mean to say like this, let us say we have a symmetric relation like this, a comma b and a comma c. Now if I try to add more ordered pairs to it, at least one order pair and your wish, so can you say that every addition is going to be an asymmetric relation? Then only we can say that it is closed. Even if you can find one addition to the existing asymmetric relation so that the result is going to be not asymmetric, then we cannot say that it is closed. We can say that it is not closed, right? So if you have such an example which is asymmetric, I'll just add one element like this, b comma a, that's it. Now by adding this ordered pair, we are going to have a symmetric pair, right? So whenever we have this symmetric pair, the result is not going to be asymmetric. Therefore asymmetric relations are not closed under superset operation, right? Why? Because just by adding one element, we are making a symmetric relation, we are making a symmetric relation not asymmetric. Therefore we can say that asymmetric relations are not closed. Asymmetric relations are not closed. What about union operation? So what does it mean? What is union? If you have two asymmetric relations R1 and R2, then they are saying that union of these two, what can you say about union of these two? That is what they are asking. Now one interesting thing here is, even though the relations independently or individually are asymmetric, when we combine them we might add the symmetric pair. So what I mean to say is, even though they are individually asymmetric, which means let us say R1 is containing a comma b, which is of course asymmetric, and now R2 is containing b comma a, which is also asymmetric. Even though they are individually asymmetric, now when I merge them, right, when I merge them, then the result need not be asymmetric. Therefore what can we say? That the union of two asymmetric relations need not be asymmetric. Therefore asymmetric relations are not closed under union operation. So not closed, right? So here it is closed under subset, not closed under superset, not closed under union. Now what about intersection? Now if we have two asymmetric relations R1 and R2, now what can you say about R1 intersection R2? This is definitely a subset of either R1 and R2, isn't it? It is a subset of R1 as well as it is a subset of R2. Now intersection is nothing but taking the subset, isn't it? So since we already know that every subset of a symmetric relation is asymmetric, we can say that under intersection also it is closed. I hope you are getting the point, right? If you have R1 and if you have R2, now what can you say about intersection? Intersection is a part of R1 and R1 is already asymmetric, or intersection is a part of R2 and R2 is already asymmetric, and we know that every subset of asymmetric relation is asymmetric. got it? Including empty set. Even if they are disjoint, then the intersection is going to be empty set, and empty set is also a symmetric relation. Therefore asymmetric relations are closed under intersection, right? They are closed. What about set difference? Set difference also we can say the same thing, right? Why? R1 minus R2 is a subset of R1, isn't it? R1 minus R2 is again a subset of R1, and we know that R1 is asymmetric, and every subset of asymmetric relation is asymmetric. Therefore asymmetric relations are closed under set difference. What about complementation? So complementation is, if you have a relation which is asymmetric, what can you say about the relation to know that universal relation minus A cross A minus R? See, if you have a relation R1, R1 complement is nothing but A cross A. A is, we are assuming that it is a base set on which we are defining the relations. A cross A minus R1 is complement of it. What can you say about it? Simple. If you have a relation which is asymmetric, then what happens to the complement of it? Now if the relation is asymmetric, definitely it will not contain any diagonal pair, isn't it? X comma X type of elements. Now if you take the complement of it, it will contain all the diagonal pairs, and that is enough to say that every complement of a symmetric relation is not asymmetric. Got it? Therefore they are not closed under complementation. Got it? Okay. Now if you want to see some examples of relations which are asymmetric, it is easy. So one example is, if you see less than, the relation less than on set of all real numbers, definitely it is asymmetric. The reason is it will not contain any symmetric pairs, because if A is less than B, then B cannot be less than A, and similarly A cannot be less than A. Therefore it will not contain any diagonal elements or symmetric pairs. Therefore less than is an example. If less than is an example, you can include greater than also, right, on set of all real numbers. And on set of all sets you can include proper inclusion. Proper inclusion is proper subset operation, not the subset. So this is not asymmetric. The reason is A will be subset of itself, but proper inclusion, proper subset, yes, it is asymmetric, because A cannot be subset of A. So similarly this is defined on set of all sets, right? And similarly superset, proper superset, right? So it is also a symmetric relation. So you can find out some examples which are asymmetric like that. So how to find out is, you just try to see if the relation is supporting the presence of symmetric pairs or diagonal pairs. If it supports, then we can say that it is not asymmetric. If it does not support, then we can say that it is asymmetric. Got it? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.